ERN Hurricane. To launch the ERN Hurricane program, users have two options. The first is clicking the Windows Start button, then All Programs, then the ERN folder, and then ERN Hurricane icon. This displays the main program window. The second is to launch the program from the desktop by double-clicking the ERN Hurricane icon. In this window, all the required data must be entered to estimate risk for the three most important hazards associated with a hurricane: wind, storm surge, and rain. Entering data into the ERN Hurricane software. Once the program is running, define and assign the data that ERN Hurricane will use to compute the wind, storm surge, and rain hazard scenarios. For this purpose, ERN Hurricane separates data entry into the following sections: General Data, Analysis Zone, Hurricane Trajectories, Simulation Parameters, Drawing Options, and Hazard to be computed. In the following example, all data will be entered for the Capra Island model. Entering General Data. In the General Data area, to enter the topography data in the model, double-click on the first text box. This will display a window where the file with the topography data for the model can be selected. In this case, the file located in the topography folder has a DAT extension. Select the file and click Open. For the bathymetry data, follow the same procedure. Double-click on the second text box. A dialog box will appear where you search for the bathymetry folder. Select the file with the GRN extension, which contains the bathymetry data for the model. Select the file and click Open. The same procedure is used to enter the wind exposure factors data. Double-click on the third text box. In the dialog box, search for the wind factors folder, locate and select the DAT file containing the data for the model, and click Open. To enter the roughness factors for soil type data, double-click on the fourth text box. In the displayed dialog box, search for the roughness factors folder, then select the shape file with an SHP extension with the polygons for different urban areas in the island. Select the file and click Open. Lastly, to enter the reference map for the area to be analyzed, double-click on the fifth text box. A dialog box will be displayed where you search the Map of Reference folder. Select the SHP file and click Open. To check that the data entered is correct, in Drawing Options select Topo, Map, and Soil Type. This will display in the drawing area the different data selected. Entering data in the Analysis Zone. For entry of data in the Analysis Zone, the program has two areas. One to add to the model the points in shoreline data to estimate storm surge, and the other for the boundary geographical coordinate data and distance between points for characterization of a grid used in wind and rain analysis. To add to the model the points in shoreline data, double-click on the first text box. In the displayed dialog box, search for the Points in Shoreline folder, select the file with the DAT extension, and click Open. This file contains the points that define shoreline cross-sections for analysis of storm surge flooding. For wind and rain analysis, the limit coordinates defining the area of study can be obtained by placing the pointer in the drawing area where the island map is plotted. In this drawing area, the maximum and minimum latitude and longitude can be identified. In this tutorial, the following coordinates are used. Minimum longitude, -80.4 degrees. Maximum longitude, -77.4 degrees. Distance between points, 0.10 degrees. The program then calculates 31 points for the grid in the longitude direction. Minimum latitude, 13.3 degrees. Maximum latitude, 19.6 degrees. And the same spacing, 0.10 degrees. The program then calculates 64 points in the latitude direction. To display the grid of points with the defined spacing characteristics or the shoreline cross-sections, in the Drawing options, select Grid, and in the Hazards option, select Wind, Rain, or Storm Surge, depending on the plot you want to see. For example, we can see only the grid for wind, or we can see the cross-section for storm surge, or we can see the grid for rain. Now it's time to save the project. To do this, click the Project option in Main menu and click the Save icon. This will display a dialog box to save the project in a folder. In this tutorial, we will use the Examples folder, and the name of the project will be Example 1 Hurricane Capra Island. When the name has been assigned, click Save. In the Hurricanes option, the hurricane trajectories data will be entered into the model. To do this, double-click the blank text box to open a dialog box. Find the Hurricanes folder, open it, and the Hurricane Trajectories files will be displayed. These files have an ATL extension because they are related to Atlantic Ocean hurricanes. In this tutorial, the 22 hurricanes trajectories will be entered into the project. The user can select any or all trajectories. Once they have been selected, click Open to load the files into the Hurricane tab's main window. If required, scroll down to check the paths of any files. Now it is time to save the project again. To do this, click the Save icon in the toolbar, find the Examples folder, and update the file. The last parameters to be entered into the model are the characteristics of the probabilistic analysis to be run. ERN Hurricane has 3 simulations options: Group of Simulations, Pure Simulations, No Simulations. For each of these 3 options, parameters based on tests and calibrations of the program are suggested. For the Group of Simulations option, it is recommended to enter 100 as the number of simulations and a sigma value of 0.5. For the Pure Simulations option, it is suggested to enter the same parameters as those used for the Group of Simulations. Finally, for the No Simulations option, it is recommended to use a coefficient of variation of 0.4 for wind, storm surge, and rain. Now it's time to save the project again. To do this, click the Save icon in the toolbar. Find the Examples folder and update the file. In this video, we will run the wind hazard assessment with no simulations for all parameters previously entered into the model. Select the Wind option in the Hazards area and in the Simulations tab, select the No Simulations option with the parameters entered into the program. This example is now ready to be saved by clicking the Save icon in the toolbar. Save the project with the same Example 1, Hurricane Capra Island Wind, No Simulations. Once the project has been saved, click the Compute AMI icon in the toolbar. The AMI metadata dialog box is displayed with a brief description of the AMI characteristics. Review the data, change as necessary, and when everything is OK, click Accept. To start the hazard assessment for the selected options. The program will show the progress of the computation. In this case, wind hazard assessment with no simulations for the 22 hurricane trajectories selected. When the evaluation has finished successfully, this message window appears, indicating that the AMI file has been created and that the assessment has been completed successfully. Click Accept. The AMI file was saved in the Examples folder, where the user previously saved the project. This AMI file will be used in Capra GIS for risk assessment. The user can run other assessments for different hazards, number of hurricanes, and simulation characteristics. This concludes the tutorial. Thank you.